morning. This is the video for OP1 of cutting the 5-inch soft jaw. So here we go. Like always, we start with setup. The trick here is that we're going to flip over to stock first, and we're going to fix this to a fixed size box. 5.5, 2, and 1. We're using 2 by 1 inch stock that we will cut to 5.5. We do not want the stock in the center. We want it pushed all the way towards the top, so we go offset from the top, and we're going to change this to 0.03, so that we're going to shave on the facing operation a sliver off the top and leave a lot to grip on the bottom. So then we go over to setup. I happen to have this pointing the right direction. Z is up, X is the long direction, Y is the short direction. But if you did not, you would use these commands to adjust your direction. So let's say I was messed up like, oops, let's try. I was something like this. Then I would come back here and I would select the Z axis, choose a vertical edge, flip that, choose the X axis, choose the long direction. I'm going to flip it because I want it to go the other way. And we would have it set up in the right spot. If the origin here was not in the right spot, you can select the box you want. I want it in the center top. Post processor, your last 4 digits of your student body number are what you're going to use. I'm just going to use 1111. And then under work offsets, this we never use G54, which is 0, so we are going to use 1, which should produce G55, and you click OK. Our setup is now done. Our first operation will be a facing operation. Essentially, we select the tool, our 2.6 inch facing mill, which is really our 3-inch facing mill, and we click OK. And really, you don't have to adjust anything else on the face. You just click OK. Oh, I take that back. Edit. We want to extend the cutter beyond the part so it doesn't leave kind of a half circle here. So we're going to extended pass. We're going to add half the diameter of the cutter, or 0.125. And now you can see that the blue line comes all the way off. Our next operation is we need to do a clearing around the outside. So we're going to do a roughing and then a finish. So we do 2D adaptive clearing, which is our roughing. Our tool will be the 3/8 end mill. Our tool will be the 3/8 end mill. Our geometry is we need to select the outermost edge, which is here. And that will produce this. The problem we have is that that's not the bottom of our part. We need to force this not just to this point, but beyond it. So when we flip it over to do OP2, we don't leave a little feather edge along it. So if we go over to heights, we have to first go to passes and notice stock to leave. Right now it's going to leave on this wall 0.02, and it's going to come from this blue line up 0.02. So we're going to turn that 0.02 that comes up off. And then we are going to tell this not only to cut at this edge, but to drop to here plus a little bit. So from here to here is 0.02, or 20 thousandths. We're going to go to the 10 thousandths, or negative 30 thousandths. And click OK. And the blue line should appear right there. So below the surface. That was our clearing. I did forget one step, so we're going to go in here. I prefer us to run around a 0.25% optimum load, so we're going to run that at 0.08. And that will give us an extra pass. Now we've got most of the material out, it's time to go back and do the final pass. So we're going to use a 2D pocket. This is the finish pass, same area. We're going to drop this down the same amount, 30 thousandths. And that's all we need to do, and we click OK. So it's going to come around and do a face, do a contour or an adaptive clearing, and then the contour. Next, we're going to tackle these pockets in here. So we're going to go back to 2D adaptive clearing. We're using the same tool, so I didn't check that. We're going to select both surfaces. All this is good. One problem we're going to have is this default setting for the 3/8 tool for the helical in is too large of a diameter. We need to lower that down to about 1/4 of an inch. And if we click OK, it should helic in. Something went wrong. Oh, I put 0.025. I wanted 0.25. And click OK. And there we go. It's helicing in. I forgot again. Optimum load 0.08. And we can click OK. Now it's going to helic in. It's going to remove most of the material, but it's going to leave material on the floor and on the wall. Because the floor is so narrow, we do not need to use a pocket to get all that out. We could just use chamfer. So we're going to go 2D contour. We're going to select that edge and this edge. We're using the same tool. The geometry is the same. All we need to do is click OK. And you can see there that it's going to feed down and cut it. So let's take a quick simulation. Speed it up just a tad. And we hit play. Goes around twice. Finish pass. Helic in. Clear out the material. Clear out the material. Final pass, final pass. Perfect. Next, we need to get this lower area done. The cutter is not big enough to do an adaptive clearing, so we're just going to go straight into contour and select the bottom edge. Notice I selected this side first because the cutter ended over here. It should start the next operation right here. We want to use ramping. And what we want it to do is we want it to go kind of around in a ramping pattern to get to the bottom. So we're going to go ahead and click OK. And you can see it makes that ramping pattern. But it's very time wasteful to ramp through all this space. As you can see here, we want it to kind of start the ramping down here, not way up here. We've already cut that out. So what we're going to do is we're going to go in here and we're going to edit this. And we are going to change the top of stock to selected section. And we're going to choose that section. And then we're going to click OK. And now you'll notice that it's going to plunge down in most of the way, have a little bit of startup before it starts cutting. We do need to push it beyond the bottom, which I forgot. So let's first read this log and figure out what's wrong. Oh, it doesn't like the linking. So we'll change two things. We don't really need the lead in and lead out. So let's go ahead and turn both of those off. And under the bottom offset, we're going to push it -0.1 or 10 thousandths so that we can make sure we cut all the way through. And there you go. And you can see that it's getting all the way through. Now we're going to put on, now we need to put our chamfers on. So we're going to go, I like chamfer with 2D contour. We do need to change a different tool to tool number 3, the chamfer mill. We need to select our contour, which will be the outermost edge there, there, and there. We don't want to adjust anything here. We do want to adjust tip offset, so we're working in the stronger part of the cutter. So I'm going to go 0.08 and we can click OK. Notice it offset the line down and to the right, which will then give us our chamfer at a stronger part of the bit. And if we simulate this and hit play, speed it up a little bit. There we go. It's looking good so far. Should come back. And there we go. OP1 is all done. So we can go ahead and hit close. We can minimize this and we can go set up again. And this time we want to do OP2. Now we need to flip. So the stock is now still a fixed size box, still the same sizes. It's now offset from the bottom 0.03 because that's what we, 30 thousandths because that's what we did before. Now the problem is it thinks the bottom is still down here. Under setup, we are going to switch the bottom by flipping the Z axis. So you now see that it's still a 1-inch stock, because that's what we started with, but the same 30 thousandths we had to offset from the top here, we now have to offset from the bottom because it's actually gone now. And then we need to change the orientation from stock to model, and we are going to select center bottom of the model. So now we need to go to post processor, and once again we need we're going to use our student body number again, because you're not going to actually load these on the machine, you're just going to work off a flash drive. But the offset now, we use 55 for G55 for the OP1. Now we're on OP2, it's going to be G56, which means it has to be 2. And then we can click OK. We are now going to just face the back and then chamfer it. So we're going to go ahead and do a face mill. Select our face mill. The only thing that's here is we really can't hog off all that material in one pass. So we're going to do our maximum step down as 40 thousandths. Oops, not 400 thousandths. 40 thousandths. And it should give us like 3 or 4 passes to get this done. And we want to extend it. We don't need to extend it. We'll extend it past 1.5. And we will go OK. So there you go. I think it's 4 passes. And that should get us all the way down to this surface. The last step is we're going to chamfer the outside. So we go 2D contour. We're going to select this outer edge. We have to change it to our chamfer mill, which should be tool number 3. And just like before, we are going to do a tip offset of 0.05 just to give it some variety, so we're using different parts of the mill, and click OK. So now if we click on this setup and we hit simulate and we flip this thing over, it should do the whole thing from start to finish. Now we can flip it so we can see what it's doing. We now flip the part over, and there we go. We have the soft jaws the way we want it. Okay, now that we have OP1 and OP2 all done, we need to post-process these. And we're going to post-process them separately into 2 different codes. So we can see we have all that and that. So we're going to start with OP1, setup 2 here, or OP1, and we hit post-process. And we want to make sure that we select HOS, pre-next-gen controller. We want to make sure we have our program number here. And then we want to name it something that's logical. This is soft jaw. And then I would put OP1 for operation 1, and then your last name. Okay, and we should go ahead and be able to hit post. And it's going to ask us where we want to post it. I'm just going to post it here. And there it is. Shoot. So I made a mistake. Apparently 0 and 1 both produce G54s. So what we're going to do is we're going to have to go back into here and go edit, post processor. And we're going to change this to 2 and click OK. And then while we're at it, we're going to go ahead and change this one to 3 and click OK. Now let's try posting again. Everything should have stayed the same. So we hit post, same spot. Yes, we do want to replace it. And now it's producing G55s, exactly what we want. We would now take this and save it, and then take it out to the simulator. And make sure you check the simulator sheet for which 2 simulators you can run OP1 on, and then it's 2 different simulators for OP2. I have 4 simulators. Now, we have one last thing to do. So we'd save this on a flash drive. For our engineer's notebook, we are going to create what's called a setup sheet. And we go ahead and click on this. I'm going to save it somewhere where I know where it is, the downloads folder. Select folder. Here is a setup sheet. This tells us all the important information about at the beginning, stock size, maximum spindle speeds. I'm going to check, here's the tools you got to use. I'm going to check all this over before I let you run it. This has got to be cut out. You can cut them out by section and glue them into your engineer's notebook. So go ahead and print this out, and then you are ready to go simulate.